So it's amazing what a weekend can do. I feel alive again, because last week did not feel that alive. Now, I hope everybody had a good weekend. So this week, I've went ahead and posted this week's assignments. They are 4 exercises on doing turtles. So like you have 4 things you need to do: draw the Olympic rings using turtles, draw a clock using turtles, draw your initials using turtles, and then draw an n-sided polygon. One of these things is not like the other, right? So you've got 4 small assignments to do there, and they shouldn't be too bad. They're not nearly as difficult, I feel, as the if statements that you've had to deal with. So we're going to learn about if statements, or not if statements. We're going to learn about sequences today, and maybe we'll get into learning in more detail about for loops. So what I'm going to do here is that the last thing I need to do before we can go on is we've learned about some Boolean statements like 5 is greater than 4, right, and that will return true, right? So we've learned about like layers less than or equal to, greater than or equal to, greater than, and double equals to, right? And we'll learn more about the logic in that, like the nots and the ands, in a bit more detail in the chapter after the loops. But there's one that, since we're getting into sequences, that I think is really important, which is a special word called in, which has so many uses in Python. And it's kind of intuitive as to how the in statement works. For instance, so if there is for instance, let's go ahead and check the truth of this statement. Bat in Batman. That returns true, right? That's fairly straightforward. Is there a bat in Batman? Yes, there is. Also, and it doesn't matter where it is, right? Is there man in Batman? True, right? Man is in Batman. Is there fear in Batman? No, there is no fear in Batman, and never will be fear in Batman. Okay, right? False. Okay. So you can use these so you can use this fairly straightforward in a very straightforward manner. We can ask, is there a B in Batman? That's going to return true, right? Is there? And you can do this for as much of a sequence as you for as big a sequence as you need. So you can use this the in statement basically to check if something is in something else, right? If it contains something else. It's very useful. Later on, we'll see when we're dealing with the lists. Like this is a list of numbers, 12, 3, 1, 5, 7, 3. I can ask the same thing, is 5 in this list? And yes. We're going to get into lists today, by the way. And how they work. But basically, this in statement is very powerful, and we'll see it a couple of times. We can also use it to count things, or when we're counting things. So, now, as you kind of notice with the 3 sort, there's kind of a limit to variables. Variables only ever hold one thing. Only one. So we have these sequences or collections to get around them. Now, we've seen int, float, and string. These are primitive data types, but typically we work with a lot of what we call collections or data structures, which are like strings, where strings are not just one, like an integer is just one number. They might have a lot of digits, but it's still just one number. A string, on the other hand, is built up of a lot of different characters. So we're looking at things that are like that, where we can have a list, we have a string, or we'll have a tuple. And we're going to learn that basically, fortunately, unlike other programming languages where basically manipulating them is completely different. So, for instance, for lists in Java, I have to use .get and .set, and then but for arrays, I have to use indices, and for strings, I have to remember, for arrays. So yeah, in Java, I really want to just illustrate this, okay? because this makes me so mad. In Java, if I want to figure out how big an array is, I ask array.length, no parentheses. If I want to figure out how big a string is in Java, I say array.length with parentheses. And if I want to figure out how big a list is, or any other collection is in Java, I say .size with parentheses. And I just simply know which to use because, of course, I've made the mistake of using the other ones a bunch of times. You learn by trial and error, mainly error. So, fortunately in Python, everything, be it a list or a string, gets manipulated the same way. All right? So big things are strings and lists, and you guys can go through these fairly straightforward. But strings are sequences of characters from left to right, right? So Batman is a string, fear is a string, man is a string, bat is a string. This is a string as well. It's a special string. What is that string? It's empty. This is a space. This, on the other hand, is the empty string, which is kind of the string equivalent of 0 in the sense that basically if I did the letter B plus space, I'd end up with B space, right? Everybody see that? But if I did B plus empty string, I end up with the same thing I started with, right? So it's the 0 of strings. Now again, you can use single quotation marks for strings as well. So Batman is perfectly fine. And the advantage of using single quotation marks or double quotation marks is pretty awesome. So for instance, if I'm using double quotation marks, this is Batman's car, right? That's perfectly fine. However, if I wanted to say this is Batman's car, the Batmobile, and put quotation marks around it because I'm super skeptical about a person who brands his own car, gives his own car a name, the Batmobile, right? I get into that issue where I have to escape these characters, right? This is Batman's car, the Batmobile. Everybody understand why I have to escape those characters? Now, interestingly, and an interesting thing happens in reverse if I have to use the single quotes, right? If I use the single quotes, then suddenly I don't have to escape these quotation marks, but I have to escape this one because that's what's being used to denote the beginning and ending of a string. Does it make sense to everybody, or have I helplessly confused everyone at this point? Right? This is Batman's car, the Batmobile. And I didn't need to escape this because we use single quotes this time around. But I had to escape the single quote because I was using the single quote to say this is the beginning of an ending of a string. Most of the time, you don't have to mix and match like that. But if you want to use just something like this, he said boo, I don't have to escape anything now. That's pretty cool. So there's one more way to delimit strings, and that is to do as follows. So I'm going to go and say sentence is equal to triple quote, and that can be either single or double quote. Okay, triple quote. It's actually the sentence there. Triple quote. This is a multi-line string. Say hello, multi-line string. and then I can stop it between this. And a multi-line string, oh yeah, let's go ahead and put that new line in there. So a multi-line string begins and ends with 3 quotation marks, either single quotes or double quotes. If you use single quotes to open it, you need single quotes to close it. If you use double quotes to open it, you need double quotes to close it. But it will pretty much, but inside of here, you pretty much will need to escape nothing. We do, well, notice this is a multi-line string / new line. Say hello, /n, /n. This is going to go on until I stop the string, right? So it's a nice way to basically, if you need to format a paragraph or something. This isn't used too often, but when you want to use it, you're glad it exists. So there's not going to be any trick questions on exams about multi-line strings or anything, right? I'm rarely going to use them. Most of the time, actually, they get used as comments in multi-line. They serve as multi-line comments for functions, as we'll see. So that's so we've learned about strings. So now a string is a bunch of characters, but there's a more abstract collection, which is the list. So let's take a look at a list. I'm going to call my first list L. And this is how I create a new list. Looks pretty abstract over here. This creates a new empty list. Open bracket, close bracket. So that's right above the quotation marks. And very nice and coincidental that. Well, they're open and above it on an English keyboard. It may differ if you've got a non-English layout. So this is an empty list. Watch, boom, print L. It's empty. Nothing really to it. Okay? So let's go ahead and I can also populate basically a list of a non-empty list like this. So L is equal to 1, 2, 3, 4, 5, 6. And now L's equal to all these numbers. Or it contains all these numbers. It's one variable that holds a bunch of numbers in it. Right? And when I say list, I actually do mean a list, like a shopping list or a to-do list. Right? We'll learn that we can add items to this list, we can remove items from this list, we can swap items out, we can see what's the first item, what's the second item, what's the nth item in the list, we can ask how big the list is. All the things that we can do for a list, though, we can do for a string. Now, lists can be of any type. They can hold anything in Python. So, for instance, it can be a list of words. Hello, comma, world. And this now holds this is a list that holds 2 words in it. Hello and world. It can also hold different types. So, for instance, 1 and hello, although I recommend not doing this because it gets confusing, right, as to what types you're holding. So, yeah, it says even that in your textbook that you do not want to mix types, right? Don't mix types. You'll see it in the textbooks. Don't do it in real life. A list can hold other lists, right? So we can have a list of, so for instance, this might be my, you might have 2 shopping lists put together, like, right? So basically maybe from the farmer's market, you might be getting the super organic bread and maybe if you're going to Costco or something afterwards, then you've got the bulk peanuts or something like that. Bulk peanuts. But notice that these are 2 lists inside a list. Now that's a bit confusing. Don't worry about it. We'll get into lists inside lists more often. But in Python, you don't see that too much. We try to avoid doing weird stuff like putting lists inside lists and then putting lists inside lists inside lists inside lists. That way leads to madness, and we want things to be easy in Python. Other programming languages take they're like, yeah, we're a hard programming language to learn. You got to really understand all this stuff. And Python's like, just get the hard stuff out of the way, please. There's one more type, which is called a tuple, which is in parentheses instead. And the main difference between a list and a tuple, so this is a tuple, I'll call it T for tuple, is hello, and we're not going to use tuples that much, by the way. And anywhere you see me use a tuple, use a list, you can probably use it with a tuple, but honestly, I'm not going to use tuples too much. Notice the only difference was using parentheses. Hello, tuple. The difference is that with lists, so let's go back to, let me go ahead and grab my list over here. Lists are what we call mutable objects. Okay? Hello, world, so L, and what I can do, L dot append, how are you? Question mark. And what that does is that append adds to the very end. But for tuples and strings, there is no append method. Get an error when I try to append anything. Strings and tuples are what we call immutable objects. With the list, we like to change things in lists, right? When you write a to-do list, it feels great to be able to remove things from your to-do list, right? And maybe something gets added to the to-do list because maybe your dog decided that the bathroom was actually your shoe. So that's another thing you have to add to the to-do list right there. So, we need to change our to-do list. Likewise, in Python, we like our ability to change lists. Strings, though, we don't change, believe it or not. Anytime you see basically a new string be created, or like when we concatenate strings, or it seems like we're changing a string, we're actually creating an entirely new string. So, that's the big thing about tuples. Now, let's see. So we're going to work with primarily strings because that's what we're most familiar with over here. But let's go ahead and just deal with, let's say, again, so let's go with word equals the quick brown fox jumped over the lazy dog, right? You can use honestly whatever you want. I just decided to use that one. Okay. First off, we can ask how long this thing is. Okay. Word is, well, it's not actually a word. It's more of a sentence. Let's go ahead and call it a string instead. S is equal to word. There we go. The quick brown fox jumped over the lazy dog. What I just did there, by the way, is called aliasing, where basically I simply have two variables that point to the same object. A string is an object. A tuple is an object. Basically, any kind of noun in your programming language is an object except for numbers. So, how big how big is this? It's 44 characters long. You can also figure out how big tuples are or how big lists are by asking their length as well. None of this trying to remember, wait, is it size with or without parentheses that you have to do in Java? The length of the tuple is 2. Why is this length 2? Aren't there 10 letters in it? Well, it's because there's 2 items, hello and tuple, right? Similarly, what is the length of this list over here? I heard it. 6. There's 6 items in here, so its length is 6. So the length is how many items it has in it. And for characters, for strings, that's just the number of characters it has. Now, how do I get individual characters out? So, what if I want to just ask what the first character of S is? Now, here's the important thing. S of 0 let's see if everybody sees this. S of 0 is T. S of 1 is H. S of 2 is E. T, H, E. S of 3 is space. S of 4 is, and I'm not going to do this for all 44 characters. So T, H, E, space, Q. The quick brown fox jumped over the lazy dog. So S, 43. So this is what throws people for the first time when they're learning how indices work. G, S of 44 is out of range. Doesn't exist. Okay? So let's go ahead and make a shorter string. Let's go ahead and say word is equal to just, let's go with temple. Sure. Word is equal to temple. Right? Now let's go ahead and see here. So each character in the string has what we call an index. Its position in the string. Indices start at 0 in Python and in most programming languages. And anyone who says otherwise is a heathen. I'm looking at you, MATLAB. Actually, is it heathen or heretic? I'm not really sure if it's a heathen or a heretic in this case, right? Heathens are people who have no following of your belief, whereas heretics follow a heretical belief of your own belief system. So I'm not really sure which implies in this case. It's neither here nor there. So, temple. So here we have the indices system. So 0 is a T. So here, index 0, index 1, index 2, index 3, index 4, index 5. So there's 6 total indices, right? From 0 to 5. Okay, so that I know that feels weird, right? There's 6 total. It's 0 through 5. Another way to think of it is, if you remember this range, it goes from, what is it? 0 inclusive to n exclusive, where n is the size of the whatever you're looking at, right? So it goes up to, but doesn't include its length. So this has this is 6 letters long. So the indices are 0, 1, 2, 3, 4, 5. So word. So length of word 6. Word 0 is T, right? That's the first one. So what would word of 3 be? What would index 3 of this be? Right, so to get the index, what we do is that if we've got something that's a collection, a tuple, a list, or a string, this means if we use the brackets like this right next to this variable, we say, I want the third item inside of it. This is kind of like saying, like when you're looking at when you're looking at like notations for matrices or something, like, right, second row, third column, right? Except you can't make small text on the page, just like with the exponentiation. So instead we use this bracket terminology. So word, so index 3, 0, 1, 2, 3, right? Start from counting from 0. So that's going to be P, right? So word of 5, index 5 is E. What is word 6? Error, right? Doesn't exist. What is word negative 1? Anyone? It is actually E, and this is a quirk of Python. This isn't true for any other programming language, but most times when you do a negative index in programming languages, like in Java, let's go ahead and see an array in Java just a second. Right? I know I do this comparison a lot, but it's useful to just show how other programming languages work, because this is like the one thing that if you take from Python, you cannot take somewhere else, and it makes me sad. So right? This is how you make a array of numbers, an array of integers in Java. Int array, or int r, if you want to sound like a pirate, is equal to 1, let's say, make a bunch of numbers, 3, 5, 2, and again, I'm just baking a bunch of numbers up. This is how you create an array there. It's 5 long. Those are its values. If I want to get index 0, it'll return 12. If I ask for index 4, that's the last item, right? Index 0, 1, 2, 3, 4. So it turns out it works the same for arrays and for lists as it does for strings. Item at 0, item at 1, item at 2, item at 3, item at 4. So indices are indices, whether it be strings, tuples, arrays, lists, whatever it is in any language. Okay? That makes sense? So, again, if I try to go out of bounds, I get an error. And if I try to do a negative indice in Java, it just yells at me. But in Python, glorious, glorious Python, they decided that actually getting the last character of something is a very frequent operation we do. And if you want to get the last character of something, sometimes it's easy to know what the first thing is. That's just 0. But say we don't know precisely how big word is. What is the last valid index? This one's a toughie. Well, how big is it? Well, it's the length of however big it is, right? Length of word. So if this is 200 characters, so if word is 200 characters long, length of word will return 200, right? But if it's 200 characters long, then that means the characters are at indices 0 to what? 199. So it needs to be length of word minus 1, right? If it's 200 characters long. In this case, it's 6 characters long, so this get me index 5. And we look at that, and that's... Would you agree with me that this is ugly? Yes? Okay. Some half-hearted hand raises there. Other people are like, no, the entire thing looks ugly. What are you talking about? So instead, we can use -1 to basically go in reverse. So -1 gets you the last letter, the first E in Temple. Word -2 gets the L, right? The second to last letter. -3 would get you the third to last, and so on and so forth. They have this great chart over here. Guess what college the professor works for who wrote this section, right? I bet you'll never figure that one out. So anyway, you can see with Luther College, index 0 is L, index 13, but -1, -2, -3, -4, -5. So it's actually pretty cool. And also what we were showing is that, right, this returns a new string. So basically, we can do like last letter is equal to word -1. First letter is equal to word, 0. I did, let me do -1 over there. And then we can do first letter plus last letter, right? They're strings, so I can add them. So I get T and E. Not the greatest example because, of course, because the first letter plus the second letter would also be T and E. But the first letter and the last letter, this one was a mistake over here. So, for instance, well, does that make sense to everybody? I can grab the first letter. And what this does is that this stores a new string in first letter and a new string in last letter. And then this, adding them together, creates a new string entirely. So this also works for lists. So let's go ahead and create a new list of numbers. L is equal to 0, 2, 4. Actually, because we're dealing with indices, let's keep it as strings. apple, banana. What's a C vegetable or something? Cucumber? Durian. Let's call it, and let's give it a more distinctive name than L so we don't accidentally overwrite it. Let's call it fruit. And then eggplant. I know some of these are veggies, but whatever. All right, so we've got fruit. So this is our list of fruit. How many fruit are there? Length fruit. 5 fruit in this, right? It's not the total number of characters. It's the total number of items in the list, right? Because it's a list of words. Does that make sense to everybody? It's a list of words. That's why there's 5 items in here. So what is the first word in my, so what is the first fruit in my list? Index 0. It's apple. What is the last one? Fruit, -1. Eggplant, right? What about, what's at index 3? Durian, which is apparently smelly, but the orangutans like it, so. So that's really, really interesting how that works out. Now the other thing though is that this notation this is all we can do with that notation in Java, but in other programming languages, well, let's go ahead and store var is equal to fruit -1. Let's go ahead and grab our eggplant, store it in here, right? Notice that what I've done, by the way, is that I've made a copy of it, essentially, this variable now points to eggplant as well. We'll learn more about memory. The code lens is very good for showing how memory things map. It's something you get more of an instinctive feel for it. But basically now var and the list both have eggplant in them, okay? And what we can do is that we have something called slice notation in Python. Zero, 0:3, same brackets, but this time I'm using something called the slice notation where I've got the colon. And that gives me egg. Remember, var over here is eggplant, and var 0 to 3 is egg. So, again, this over here. So what a slice does is it gets all the indices from this starting from the index up to but not including this index. So it gets up to but not including the third index. Now why is that? Why in the world do we do this? It actually makes the math a heck of a lot easier because I can figure out how big that slice is by doing subtraction. 3 minus 0, it's 3 long. If, on the other hand, I do var, let's see, I have to just think for a second. So 3 to 8, that will get me plant. Up to, but not including 8, so it's indices 3 through 7. How many characters is that? 8 minus 3, there's 5 characters in that. It's a pretty cool trait, but that's like part of the reason why we do it. What you need to know is that it goes up to, but does not include. Now, mind you, going up and figuring out the last one again is kind of annoying. And if you haven't figured it out, programmers are a bit lazy. We just like to be lazy, but we like to make it look like we're very smart when we're lazy. So we can also use this notation, 3:nothing, which also gets me plant. So we've got the beginning of a colon and the end of a colon, right? Or we've got two, when we do slice notation, we've got 2 numbers so far, separated by a colon. If we leave out the second number in the colon, that goes all the way to the end. So it says, give me a slice of this all the way to the end. So for instance, if I were to do b is equal to fruit, let's go ahead and try this. Var is equal to fruit 1, which is going to grab me banana, right? If I do var slice, and if I slice the banana from index 2 to the end, I get nana, right? Starting from index 2 of banana, 0, 1, 2, all the way to the end. Any guesses as to what's going to happen if I do it like this? If I leave out the first number? And put in, yes? What? Yep, it's going to start from the beginning and cut off at 2. It's going to give me ba. So there's two very useful shorthands for slices. This is the equivalent of me doing 0 to 2. And this is the equivalent of me going from 2 to negative, and this is the equivalent of me going from 2 to, let's say, length of var, which again is a very annoying thing to have to write. So slice notation gets you a section of something. Let's see, so length, don't need that. Right? So like for example in your book, it's got singers, Peter, Paul, and Mary. Right? 0 to 5. So 0, 1, let me go ahead. Everybody can see back there? Or do you need me to bump up the size? Okay. You've got Peter, Paul, and Mary. So singers, 0 to 5. So up to, but not including 5. Right? So that stops right up at the comma. So let's go ahead and actually make some tick marks for it to be easier for you to read. Right? We've got 0. It's always nice when you can just simply put your hand across the keyboard like that and say I'm actually doing work. So now from 7 to 11, 7, 8, 9, 10, up to but not including 11. So that's Paul. And then 17 through 21, 7, 8, 9, 10, or 7, 8, 9, and then the 20, and then there's nothing after that. So run. Interestingly enough with slices, let's go ahead and see. What if I put some big number here for the slice? It works fine, I guess. Let's go ahead and see over here. Var 2 to the big number. If you put in a number that's too big as your second number, you're just going to go all the way to the end. Useful to know. So N through M goes through but doesn't include, oh, see, they've got the banana as well. Right? So in other words, right, we've got var here. So anybody want to tell me what this will do? Var 2 to the end times 4 plus. Anyone? Right? No, Batman. See, it comes full circle. So anyway, what happened over here, we got the last two letters. So we got from index 2 all the way to the end, so the last 4 letters of this. And then we multiplied it by 4, so for a grand total of 16 characters, and added it to space Batman, which sounds like the most dangerous of all types of Batman. So We can also slice a list. As you'll see over here. So let's go ahead and create and check out our list L and start slicing it ourselves. It's easier to see in the interactive. So hello world, how are you? Not a lot of variety there. So let's go ahead and just use it still. So L, right? Again, we've got 3 things in the list. So index 0 gets us hello. L 0 to 2 gets us all the things up to but not including index 2, which would just be hello world, right? Not too much again in the list over here. But we can still use the slicing for our list. So let's go ahead and actually make a list of numbers because I can do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3.14. 1, 0, and 5. Okay. Length of L, how many numbers are there? There are 7 numbers in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 3.14, 1, 0, 5. Okay. Numbers, again, really don't matter. What we care about is the slice operation. L from 1, so L from index 1 to index 4. That's going to get me index 1, index 2, index 3, and I'll stop at index 4 and not include it. So that's going to give me 4, 5, 6, 7, 8, 9, and 3, 1, 4. Oh, L, 1. Oh, right. I used I used a comma rather than a colon. My bad. Okay. There's also other things we can do with a slice. I'm going to just do some. So forgive me a second. I'm going to just do some magic over here. Okay. And I'll explain what the magic is or I'll explain the magic. But L is equal to list. So the list. By the way, any guesses what the list function does? What does int do? Turns it into an int. What does the string do? Turns it into a string. So what does a list function do? Yes. Yes, turns it into a list. So list range 100. Range gives me a range object, which is just something simply we can go through. And a list will turn it into a list. So now if I do this, this gives me the numbers 0 up to but not including 100. We're very fond of that 0 but not including, right? So just it was a quick way of me generating a list of 100 numbers. Okay, make sense? Right, that's the magic. Okay, just generate 100 numbers. So, because I wanted to do something that was a bit, so L 0 through 10, I'm going to be explicit over here. 0 through 10 gives me 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? 0, so it gives me the first 10 numbers, indices 0 through 10. Now, let's take a look what happens if I add the last part of that we can do with the slice. 0, 10, and 2. Wait, what? Okay, so now if we do our last thing, let's go ahead and run it and see what happens. 0, 2, 4, 6, 8. Okay, let's go ahead and play around with this a bit. So what if it was by 1? By 1 is the same as leaving it out. By 0 gives me slice step cannot be 0. Oh, step. That might be a good. So going by slice step of 3 gives me 0, 3, 6, 9. Let's go ahead and see what was our, not B, but var. What was var? Var was banana. So if I do, var 0 through, there's 6 characters in it, and then 2, BNN. So by default, the slice step is what we call 1. which is basically meaning we just want all the items one next to each other in the slice. But a slice step means this is how often we want to jump over something. So when we have a slice of a step of 2, we start skipping items. We go from 0 to 2, then 2 to index 4, then 4 to 6, 6 to 8, 8 to 10, and so on and so forth. So 2 is every other item. 3 means we start skipping by 3s. What's cool about this is that I can totally do this, right? Blank, blank, 2, right? What did I say for if we leave this blank, it means the beginning. If we leave this blank, it means slice to the end, right? From the beginning to the end, right? So interesting. By the way, that's the easiest way to copy a list in Python. Or string, which is just to say slice over the entire thing. So if I put 2 there, it would just get me the first 2. But if I suddenly do colon, colon 2, that gets me 2, 4, 6, 8, 10. It gives me all the even numbers. Or in other words, every other number. Now, why is that? Technically, it gives me everything at the even indices. Why is that? Well, over here, L, when we leave it out, that's a 0. When we leave out the second argument, that's a length of whatever it is. And when we leave out the step, it's however big it is. Or when we leave out the step, it wants however, it really just wants every item, so 1. So again, every even item over there, L. So that leaves me to one last thing for slices, or at least any guesses as to what this does? Based on your previous knowledge of -1. Yes? Yes, it does. It puts them backwards. That's bloody convenient. So, right, basically this is saying, I want the entire thing, but go down the other way, please. I don't know why it does that, but it does, which is really cool. But essentially there are 3 steps to it, which is your beginning, so your beginning, your end, and then your steps. So again, these work on tuples and on all other other things. Let's see. So let's see. See if we can run. Boom, boom, boom. So we saw, by the way, that with strings, by the way. So here's our var again. We could do this. Var, right? We already saw the whole na-na-na-na Batman thing, right? We saw var 2 to the end times 4 gave me na-na-na-na-na-na. Okay? We saw that already. Right? We can multiply this. This is called this is called repetition. The repetition operator. And I wouldn't have known it had I not just seen it on the thing, because I didn't know what to call it. It's not really used in other programming languages. But var, so this is the repetition operator. Now we can do the same with lists as well. We can do L times 2. It doesn't multiply everything in the list by 2. What it does is that it creates a new list with all the elements repeated twice. So 0 through 99, 0 through 99. Or if we were to do words is equal to hello world. Actually, that's not Pythonic. It should be spam and eggs. Words times 2. Spam, eggs. Words times 10. Spam, eggs, right? We can also do we can also do spam plus eggs. So basically what I'm trying to show you is that Everything you can do with a string, you can also do with a list. You can add them, you can concatenate them. They all work the same way. Using indices, using the slice function, they all work the same way. You don't have to learn one different way for each variable. Python's awesome. It provides one way to do it for all these things. So what have we learned so far? We've learned about indices, we've learned how to slice them, and we've learned how to say how big these things are. All right. So let's go ahead and do another one. Let's see. It says, what next? Count and, what's the other one? Index, right. So these two are pretty interesting. So let's see. So words, let's go ahead and say words is equal to words times 10. So that actually will store words. They'll actually store spam eggs in there 10 times, right? Spam eggs, spam eggs, spam eggs. So we've got that. So now let's go ahead and do see the count function, which isn't a function, which is a function that the object performs itself. Words.count eggs. There's 10 eggs. Count basically says, given this thing, count how many times it occurs. So notice that there's 10 eggs in here. 1, 2, 3, 4, 5 times 2 gives us 10. Words.count Vikings. 0 Vikings in our spam and eggs skit at the moment. Or the list, rather. Okay. So the other thing we can do is index. So count is fairly straightforward. It gives you the count of basically anything. You can use it for single characters. You can use it, so like, again, for var.count a, count how many a's there are. There's going to be 3 a's. Count how many nas there are in banana. Count dot na. It'll say 2. There's 2 nas. Make sense? Okay. This is actually going to be interesting, I think, which is test is equal to a. Test.count AA. Because I'm actually not sure what the answer is going to be. Is it going to be 2? Is it going to be 1, 2, 3, 4? So is it going to be 1, 2, 3, 4? It's going to be 2 A's. So it's going to count basically how many completed sequences. It's not going to do that weird game of like find the 10 hidden triangles in this figure or anything. It just counts 1, 2, 1, 2. It goes on from where it left off. So let's go back to our words for a second. Words.index of eggs 1. What the index function does, it returns the first instance of the object of what you're looking for. So in other words, I ask for eggs, it finds me the first eggs. If I do words dot append, so I'm going to go ahead and add this to there. Words dot append the word Viking, right to the end of spam and to this words, right? Spam eggs, and then we've got Viking at the end. If I ask, I can then go words dot index Viking, and it'll give me, oh, Viking occurs at index 20, right? So it gives you the index of the, so index counts the number of things, index gives you the index of the first thing in there that matches, right? If I were to do index of spam, it would give me 0. Eggs, it will give me 1. Viking, it will give me 20, because that's the first index that occurs at. Questions so far? No, I'm going a bit fast there. So, honestly, I think we are... Ah, yes. So finally, we're talking about lists and strings. So it's fairly... So now, if you turn a list... Oh, so let's take a look at banana again, okay? If we look at our list of our banana over here, it actually does something very interesting if we throw it into the list and we want to turn it into a list. It basically does turn it into a list, but each individual character is its own character. So B-A-N-A-N-A. Right, there were 2 expected outcomes of this, right? 2 logical outcomes that this could have, right? One is this one, B-A-N-A-N-A, right? So split it up like in 1 letter at a time. The other possible outcome of this was that we would have a list of 1 element, with banana being the only element in it, the only item. But Python, it says, oh, if you give me a string and turn it into a list, I'm just going to go ahead and turn it into a list of 6 characters, or a list of however many characters are in it. So, what about? So, is there a more useful way we can take something and turn it into a? And is there a more useful way we can turn strings into lists? Cliche is equal to, it was a dark and stormy night. It was raining, overused lines left and right. Period. Okay. So there's our cliche. Cliche. It was a dark and stormy night. Okay. So what we can do is that strings have the split function, which is actually pretty cool. Now, what did the split function just did? It did what exactly it said on the tin. It split the string into a list. It was a dark and stormy night. Specifically, it split it up by spaces. Right? Everybody see how basically all the spaces are removed, right? Dark and stormy night. Notice that the period is still here. We'll learn how to deal with that later, much, much later when we get to regexes. We can also use, or if we want to split it up into a list of sentences, we can do cliche.split until I'd like it to split on periods instead. It was a dark and stormy night. It was raining overused lines left and right. And then an empty string. So why is that? Well, remember, it's a dark and stormy night, period. It was raining overused lines left and right, period. Okay? So the period over here, so here, when I did cliche.split, I asked it to not, if you put in nothing, it will split on space by default, and basically split up the string into sections based on the spaces. So it was a dark and stormy night. All those are separated by what's called a delimiter, specifically a space. That's the fancy name, but basically you can also call it the separator. We're saying this is how we want to separate these out. And notice that basically anywhere there's a space, it takes out the spaces and puts it, and basically uses that to say this is a new word, this is a new element. Here, since I put in a period, it grabs, it was a dark and stormy night. It was raining dogs left and right. And then it says a period. What happens after the period? Empty string. So that's why we have an empty string here. For the split, we don't get it because it automatically knows to stop over here. Let's go ahead and try another one. children's book is equal to one fish, comma, one fish, two fish, red fish, copyright notification from the Seuss estate. So there we go. Let's try this one again. So one fish, two fish, red fish, copyright notification from the Seuss estate. So children's book dot split on the period. We'll do one fish, two fish, red fish, and notice it doesn't end over here. Right, we don't get an empty string because there's no period at the end over here. Also notice because we're splitting on the period, we get a space over here. The splitting most of the time will just simply be splitting it up into words. This is really useful if we want to just simply go through a file and just check how much stuff. We're going to learn about file reading and writing. We're going to use it a lot, and it turns out it's very painless in Python. It's actually the part of Python that I fell in love with and made it my favorite language because it worked exactly as I expected it to. Unlike other languages, C, early Java. So the join we'll learn about a bit later because we'll learn about the join now. Now the join's a bit different. So the join is basically, well, the join is weird. So let's go ahead and look at a list of, let's go ahead and take our list, let's see. Actually, it's not too bad once I explain it like this. So list var, God, I'm creating so many variables. Letters is equal to list var, right? Var is banana. So letters is equal to B-A-N-A-N-A. So how would I combine this list of characters into a single word again? And we do that with the join method. Now the join method, basically you take some string which you want to act as the glue to join things together. So here I want to join things together using the empty string as the glue, that's the weird part about it. So you use your glue and then you say dot join and then whatever you want to join together. So in this case, letters. And it'll join together with letters. If on the other hand I say I want to glue it together with spaces, you're going to get B-A-N-A-N-A separated by spaces. If I say I want to separate them by the smile emoji, will that work? Yeah, slightly smiling face emoji. Great. Control V. No? Or let's see. Maybe I just need to copy paste it in because I think it should be doing Unicode just fine. Copy, paste. Yeah, that should work just fine. Oh, really? Come on. Paste. No. For shame.
The copy portion, like right there.
Ah, copy. Let's see how well that works out. No, it's just not giving it to me. What's the Unicode combination for these things? You see, now I'm bugged. Smile, Unicode. And now I'm trying to remember how to do this in Python. Because, was it? Yeah, that's not going to work. Or, yeah, that doesn't. I'll figure it out later. I was trying to be clever and put smiles all between them, but then we could move on to doing claps between them because that would totally be useful in your life. But anyway, But anyway, you can use any character you want to join these characters together. Any character. I don't want to close it. Cancel. No. We can use any character as the glue. So, for instance, we could use NA as the glue for banana, and it will turn it into banana. Well, you get the picture. The issue with spelling banana is not starting spelling banana, it's stopping spelling banana. So, but here, right, you've got BNA as the glue, and then A, then NA, then N, then NA, A, then NA, and, right? So the NA is put in between every single character. So join typically looks like this, where you just join with the empty string. But you can split and join characters together. So, all right. So finally, let's go ahead and learn how to do this with for. So now let's go ahead and move on to the next section, which brings us to the next chapter, which is for loops. So let's bring it all together now. Multicolor.py. Import turtle. Bob is equal to turtle dot turtle. Colors is equal to red, green, blue, purple, black, brown, red again, yellow. Okay. By the way, notice that you can have duplicates in a list. Just, I don't think I formally mentioned that. It was heavily implied, but you can have duplicates in a list. All right. So this is pretty cool. So we've learned about how to make a for loop. We've kind of learned about how to make a for loop do something multiple times. But this is the more common way we do for loops in Python. For color in colors. That actually almost reads like English. In other words, for every color in the colors. This variable doesn't really matter. We can call it whatever we want. We could call it for x in colors, but I prefer to do for singular in the plural. For color in colors, Bob dot, what is it, color is equal to color. Bob dot move or Bob dot forward 50. Let's go ahead and run this. Let's go ahead and make that easier to see. Bob dot pen size 5. And I don't know how well the lighting looks over there, but I think you can tell that this is red, this is in green. Let's go ahead and up it, the size, quite considerably, actually. So that's up to 50. So what did I just do there? Well, I have a list of colors over here. And then I said, for color in colors, Bob, change your color to that color. So the first thing it changed itself to was red. Why did it change itself to red? Because red was the first color. Right? We can actually print this out so you can see it. Print color. Really? Phone call right now? Spam caller. Andrew's Guns and Ammos. If we can't kill it, it's immortal. It's automated. So anyway, we run this program, and it goes red is the first color, green, blue, purple, black, brown, red, and yellow, right? Red twice because we had it in there twice. Red, green, blue, purple, black, brown, red, yellow. So the turtle followed all the directions and moved accordingly. And the turtle's just kind of hanging out there, unseen, camouflaged in the yellow. That's why you don't see him. Because he's using a pen stroke that's bigger than he is. Now, what's cool about this is that this ran a total of 8 times because there were 8 different colors, or 8 items in this list. So for the for loop, we really use it for 2 things in Python. We use it to count the number of times we want to do something explicitly, or we use it to iterate over something, why it's called an iterative statement. We can iterate over a list, we can iterate over a string, we can iterate over anything that is iterable, which all collections are. So we can add another color in, by the way, over here. Red, green, maybe cyan is a color? I hope so, because if it's not, it'll crash. Cyan, right? What else was there? There was also, I think we could do it like this. Bam. FF00FF? I think it, yeah, I thought that was fine. FF00FF, that was a color code, if you remember. We didn't really use those, but that means as much red, green, blue. As much red, as little green, and as much blue as possible. Which gives us, right, this kind of color over here, a red and a blue. So we have all these. So it's really, really interesting. So let's go ahead and take a look at a for loop in another detail, in a bit more detail, in this terminal right over here. So let's go ahead and look at this. So word is equal to eggs. For x in word, print x. EGGS. So when we use an iterator like that, it will go through every single thing in the list. It's pretty cool. Or the string. Right? Let's go ahead and make our magic list again. So nums is equal to list range 0 to, actually what we could, interesting thing about range, what we'll learn is that it works exactly the same way it works very similar to the way that that slices work. So 50 to 5,000 by 100s. Exactly the same order and the same way that slices worked. So there's our nums. We'll learn how to use range more on the tomorrow. We'll learn more about it on Thursday. But here's our numbers. For number in nums, print number. And it prints all the numbers out. It goes 50, then 150, then 20, then 250, then 350, and so on and so forth. So you can use for x in collection to basically print out each individual item of that collection. In strings, that individual item is the individual character. In lists, it's this individual thing. And this is the naive way to do it. We were kind of doing that a bit with the range function a bit earlier with the for I in range 100. And actually a bit of magic goes on over here. Print I. Because the range, what that is that it creates what's called a range object. And the range object simply is a very smart, it says, oh, if you want to go through the numbers 1 through 100, it would be a waste of memory to store all those numbers and then for you to use them only once. So instead, we're just going to feed you one number at a time. That's what the range does. It feeds you one number at a time rather than trying to waste memory by trying to make, like if you're trying to go from 0 to a million, it'd take up a lot of space. Million numbers worth of space. Here, it can just feed you one number at a time as you need it, which is pretty cool. So, all right. I feel like actually this is a great place to stop, even though it's 5 minutes early, but somehow I feel like you don't care too much that we get out 5 minutes early. So, all right. So there are readings for the sequences and the chapters. I'll most likely we'll have something to do on slices, a quiz on slices on Thursday. No for loops, just the slice notation. And I'll use and I will review slices before we go over the quiz. So I'll review like, oh, this is the kind of thing you'd see.